This is a video to show you how to do the solution to 7.5, which is telling us about or reminding us about how to do a discrete PDF now that we're thinking about sampling from a population. So 7.5 tells us to go back and look at table 7.2, which is a probability PDF. So the story is there's 5 students. And so we're going to think of them as the whole population. And if we think about the outcomes of X, then we can think about the probability of X. So we could see that with these 5 X's, there's only 4 possible choices. This one has a 1 in 5 chance, this one has 1 in 5, this one's 2 out of 5, and this one's 1 out of 5. And so in the table, they show us this is 20%, 20%, 40%, and 20%. And so what we're supposed to do is find the mean and standard deviation. So to find the mean, we have to go back and remember that the mean of a discrete PDF is taking each x times p of x. So we did this in chapter 5, and remember it's doing like a weighted average of what can happen if we picked out of those people for their scores. So if we do x times p of x, what we're going to get for those outcomes for the row is a 14, a 15, a 32, and a 19. So if we take a sum of this column, that's the sum of x times p of x, which becomes 80.6. So the expected value for the scores is 80.6, which means if we did this over and over and over and averaged what we got, each time we picked out one person, on average that would turn out to be 80.6. The next piece we're going to do is the standard deviation of that random variable, which is the square root of the sum of x squared times p of x minus the mean squared. So let's make x squared p of x over here. So just as a note, here's what the x's were that line up with this. But x squared p of x comes from 70 squared times a 20% chance. Remember that p of x itself isn't squared. And so these outcomes will become 980, 1216.8, 2560, and 1805. And if I sum that column, I'm going to get 6561.8. So that's just the sum of x squared times p of x. So now I can plug that into my formula that this piece goes in right here, 6561.8, and then this piece is the mean. It gets squared, and then I square root the whole thing. And after the square root, what I'm going to get is 8.09. So remember, this is a measure of dispersion, but now I have a random variable, so it's basically saying what's the standard deviation in the spread of these scores if I sample them over and over and over. It's about 8.09, it's 8.09% because that's the units of the scores, 8.09% on the test.